I'm going to go ahead and do our example. Y equals -3 cosine of 2 times x plus 30 degrees minus 5. All right, so we're going to go ahead and start with drawing this out and then moving the axes. So let's see. If I make every line equal to 15 degrees, I should be able to fit this in for every other line. Here's -1, here's +1. Here's our x-axis, here's our y-axis. We'll go 15 degrees, 30 degrees, and forth. All right. So our first step is we want to move the axes. So I noticed that we have plus 30 here. So I'm going to go minus 30 degrees, which is right here, and make my dotted line. And then I see that I have -5. So 1, 2, 3, 4, 5. I'm going to draw my second dotted line horizontally through -5. So just to make that clear, we have a horizontal shift of left 30 degrees and a vertical shift of down 5. Now we need to find the amplitude. So to find the amplitude, I'm going to go look at A, and the amplitude is absolute value of -3, which is 30. So I'm going to mark that on my graph, and I'm going to go up 3. So starting here, 1, 2, 3. I'm going to go up 3 and 1, 2, 3, down 3 with my amplitude as I'm graphing my graph. So that label is the amplitude change, and that is step 3. For step 4, we want to find the period. So the period is equal to 360 degrees divided by B, which in this case is 2. This has a period of 180 degrees. That means if we're starting at -30 degrees, we're going to end at 150 degrees. Let's see. We'll come back to that. Now we're going to find our increment, and our increment is going to be our period, 180 degrees, divided by 4. So in this case, we have 45 degrees as our increment. Every 45 degrees, something important is going to happen. we'd like to add the increments to our graph. So here we have negative 30 degrees, which we marked earlier. And then 45 degrees later, we have 15 degrees. And 45 degrees later, we have 60 degrees. And 45 degrees later, we have 105 degrees. And we're back at where we started, 45 degrees after. So that is 1, 2, 3, 4. Yeah, 45 degrees. After that, that's 150. 150 degrees. Okay. Give myself that my point. There's 150. All right. After we find and mark the increments on the graph, we want to plot our points. Here's the important thing that you should recognize when we're plotting these points. You should recognize that A is negative. So we're going to start low. So we're going to be at the lowest point instead of the highest point at the beginning. And at the next important point, we're going to be at the midline, which is -5. And the next important point, which is at 60 degrees, we're going to be at the high point, which is -2. The next important point, which is 105 degrees, we're going to be at the midline again. And the next important point, which is 150 degrees, we're going to be back where we started. Okay? We want to curve these through and just show that they keep going forever by putting some arrows. And that's graphing 1 period. Before I do some examples in radians, do we have any questions on graphing the sine and cosine?
Sí, lo voy a tener muy consciente, me da mucho gusto.
The number at the end here?
Sí me dio, ahí me dejó sus papeles y todo, pero la verdad ya no tuvo contacto. Me habló otra vez hace como unos 3 meses, me llamó que si necesitaba algo más, pero ya no, ya me está hablando la muchacha con la que había quedado de verme.
Oh,
Pero
that's not for
ya
us.
no le pregunté si todavía seguía en la compañía ni nada. Pues en eso quedamos. Dios me lo... Cuídense mucho, que Dios me los bendiga. Cualquier cosa estamos en contacto. Dios me los bendiga. Gracias. Bye bye.
All right. Now let's do some with radians so we can get used to it. We're going to graph y equals -3 sine of 2 times x minus pi over 6 times 4. Here's my x, here's my y. So I'm going to look first at these two. There's a horizontal shift. That's going to be right pi over 6. And there's a vertical shift that's going to be up 4. All right. So I'm going to go ahead and make pi over 6 right here for now. If it doesn't fit, I'll redo it. Okay. And I'm going to go up 4, so we'll do 1 here. We'll make 4 here. All right. Now let's look at the amplitude. We're upside down again. We have the absolute value of -3 is equal to 3. We're going to go ahead and mark that down. So here's 1, 5, 6, 7. Here's 7. We're going to be going down 3 and up 3 as we're making this graph. Next thing we want to do is find the period. The period is B. And now, it's because we're in radians, one way you can see that is, well, if it doesn't say the graph in radians or degrees, and there's no minus pi over 6, there's no minus anything, then you could do either one. But here, it's being shifted by a degree or an angle of pi over 6, which is in radians, so we're going to use radians. So a period is 2 pi divided by pi over 6. That is equal to, oh wait, now I'm writing the wrong thing. 2 pi divided by b, b is 2, so 2 pi divided by 2, so 1 period is pi. Okay, so if this is pi over 6, 1, 2, 3, 4, 5, 6. This must be where pi is. And then one more for a complete period, because we shifted right pi over 6. Now we want to find our increments. So you take your period, pi, and divide it by 4, so that every pi over 4 units, something's happening. Well, it's kind of difficult because I've marked off every pi over 6, so we want to kind of get a common denominator. Since our first point is at pi over 6, and we're going to add pi over 4 each time, we're going to want a common denominator. Well, both 6 and 4 go into 12, so that's 2 pi over 12 plus 3 pi over 12. So our increment is 5 pi over 12. So starting at our first one, pi over 6 is the same thing as 3 pi over 12. I'm sorry, that's 2 pi over 12. Is 2 pi over 12. And then our next one is going to be, so each one of these is, each time we're adding 3 pi over 12 to that. So we need to add 3 pi over 12 to 12 pi over 12, and yet we get 5 pi over 12. So there's 2 in each of these lines that I drew between the origin and pi over 6. We'll see there's 1 line, so that's like pi over 12 here. So if we're looking for 5 pi over 12, that's 1, 2, 3, 4, 5. And that's our second important point, which is 5 pi over 12. In fact, we're starting at pi over 6, which is 2 pi over 12. Then we've got 5 pi over 12, because we added an increment of pi over 4, which is 3 pi over 12. Now we're going to keep adding 3 pi over 12 here. So 5 pi over 12 plus 3 pi over 12 is going to be 8 pi over 12. So 1, 2, 3, we've got 8 pi. Oops. We've got 8 pi over 12 right here. And to that, we want to add 3 pi over 12 to get our next one. And that gives us 12 pi over 12. No. 11 pi over 12, sorry. Which is right here. And then we add 3 to that, which is going to give us 14 pi over 12. And that's where we end right here, 14 pi over 12. So each of these marks, pi over 12, then 3 pi over 12 later, 5 pi over 12, 8 pi over 12, 11 pi over 12, and 14 pi over 12. So pi over 6, 2 pi over 12, then we got 5 pi over 12, 8 pi over 12, 11 pi over 12, and 14 pi over 12. Those are all our increments. Then, finally, we just want to graph the graph. So notice that the sign is upside down. So even though we're going to start at the midline right here, so it's like our new 0, 0. At our next important point, we're going to be down 3 units. So we're going to be down instead of up. We're going the opposite direction we normally go. Then at 8 pi over 12, we're back at the midline. 11 pi over 12, we're at the top. And 14 pi over 12, we're back at the midline. And that's what you got. That's our graph of -3 sine of 2 times x minus pi over 6 plus 4. Did that kind of slow? But it lose you guys? Let's do our next one. This is the same paper. Okay. Cosine is going to be the same thing with radians. So for the next thing, we're going to go on to graphing the cosecant, secant, tangent, and cotangent. Before we do that, do we have any questions on graphing? All right, you guys are hanging in there. We're doing 4.6. Graphing. Cosecant. Secant. Tangent and cotangent. All right. So, starting with cosecant and secant. We're dealing with y equals a times the cosecant of b times x minus h plus k, and y equals a times the secant of b x minus h plus k. For the a, we're going to do, if it's upside down, but we're not going to describe amplitude, really. And the rest of these are exactly the same. And so the steps are going to be to graph the corresponding sine or cosine curve. Using dotted lines. Step 2, we're going to make the midline points become asymptotes. And we're going to flip everything else upside down. Whether or not that makes sense, hopefully with the example, it'll be clear to you. And if not, please let me know. Our example is going to be to graph y equals -4 cosecant of 3 times x minus pi over 8 plus 6. So we're going to go ahead and make this graph. So this doesn't have amplitude, but we're going to still need those points. So since I have a vertical shift of +6, I'm trying to make sure I have plenty of room to draw this graph. Matter of fact, I'm thinking of making it even lower. So we're going to still start out the same. Let's go with, it was shift of pi over 8. Let's make pi over 8 about right here. No, I'm going to use 3. Okay, because I'm looking ahead at where we're going with this. And I'm going to end up later on needing a denominator of pi over 24. So what I'm going to go ahead and do is make this 3 pi over 24, which is pi over 8. That way I'm not having to redo it later on. Okay, so just if you're following along, I have 24 little lines here on my x-axis and quite a number available on my y-axis. I'm going to make these 1 each. And so I've made each of these little tick marks pi over 24, so 3 of them make pi over 8. So there's my pi over 8, and if I've lost you, then take a deep breath, because you'll still be able to follow me even if you got lost when I was setting it up. Okay, we're going to start out, mark off where you think pi over 8 is on yours, and draw a vertical line. And then it's up 6, so 1, 2, 3, 4, 5, 6. There's my horizontal line, my midline. Okay, what we want to do is graph the sine curve. So there's a few bits of information we need for scratch work. First of all, we need the amplitude of the sine. So I'm going to do amp sub sine, meaning it's not the amplitude of this graph, but it's the amplitude of the sine graph, and that equals 4. So I know that I'm going to go up and down 4 as I'm moving through the sine curve. Also, let's look at the period. The period is equal to 2 pi divided by 3. And this is why I had the 24 dots, because I know that 8 times 3 is 24. So we're going to call one period, we're going to multiply the top and bottom by 8, 16 pi over 24. That'll make everything else a lot easier for us. We have increments. 16 divided by 4 is 4, so 4 pi over 24 is one increment. So we start at pi over 8, and then 1, 2, 1, 2, 3, 4. See, we have pi over 8 as an increment, and this is pi over 8, which is 3 pi over 24. 3 pi over 24 plus 4 pi over 24 means that this point right here is 7 pi over 24. And then we go another 4. 1, 2, 3, 4. 7 plus 4 is 11 pi over 24. Then we're going to go another 4. 1, 2, 3, 4. That gives me 15 pi over 24. And if you want to make this really pretty, divide the top and bottom by 3, and you get 5 pi over 8 right here. And then 15 plus 4 is 19. 1, 2, 3, 4. There's 19 pi over 24. That gives us 1, 2, 3, 4, 5 points. That's enough for one period. Okay, so those are our increments. This is scratch work that I use to help find my increments. Okay, once I have that, I can go ahead and start graphing my sine graph. Remember, I'm going to go down 3, and I'm going to go up 3 from here. 1, 2, oops, that's too high. I'm going to go down 3, 1, 2, 3, and up 3, 1, 2, 3. Just while I'm graphing the sine curve part. So we start at the 0, 0.
Hey, isn't it 4?
Oh, you're right. Sorry. I'm going to go down 4, 1, 2, 3, 4. I'm going to go up 4, 1, 2, 3, 4. Just when we're graphing the sine curve. Okay. So starting at 0, 0, remember, notice that the amplitude, I'm sorry, not amplitude, the A in the front is -4. So you're going to go down first instead of up first. Our first point is going to be 7 pi over 24. At 11 pi over 24, we're back at the midline. Then we're up to at the top of our possible y values at 5 pi over 8. And then back to the middle at 19 pi over 24. So this is the sine curve, if we were graphing the sine, that we'd be doing. Now it's your choice. You could draw the dotted line of the sine curve. You should for your notes. On a test, if you want to just go ahead and draw those 5 important points that I marked out, that's fine too, because that's not really part of your graph. Now everywhere where we cross the midline, so I'm going to change the color of those dots. Everywhere we're crossing that horizontal line we drew, that's actually going to become an asymptote, because that's where the sine would be equal to 0. And so when you flip it upside down, 1 divided by 0 is undefined. So these are your undefined values for the cosecant. We're making these vertical asymptotes. I write down that these are asymptotes where sine crosses the midline. Okay? Then these are reciprocal graphs. So everywhere it's not everywhere the sine is defined, we want to draw out its reciprocal. So to draw the reciprocal, just between these amplitudes here, you want to kind of mirror the look and then keep on going. So it goes on forever. So you're kind of, it's almost like you're copying it over, but then as it starts getting closer to the asymptote, it starts pulling up into a line that's following the asymptote rather than actually being the original curve. So the green, they look like parabolas almost. Those are the part that's actually your graph. So I know it's a little challenging with the increments, but how's this one? Are we good? Are we struggling? I forgot to pop out the chat box, so I don't see anything in the chat box. Anyone lost? Anyone need help? All right. If we're not lost, we'll go on to another one.
Can you stay on this slide for another minute or so?
Oh, absolutely. No problem. I want to point out that here I've got 1, 2, 3 asymptotes. And that's not going to really show up when we're doing the secant graph. And so I'm going to talk to you about 2 different ways that your next teacher will expect you to graph the secant, so you're prepared for either one.
Someone just asked, can we graph the parent function and then do the transformation?
You're allowed to do that if you make it clear. I know you did some of these graphs in Algebra 2, so you might have been taught differently than I teach it. And as long as you make your work very clear, then any of those ways are fine. But make sure you also have all those increments marked, because I'm going to be looking for them. So as long as you can go backwards and figure out what the increment points are, then I don't care how you get there. Thanks for reading that out for me. Here's our next example. Y equals 5 minus 2 secant of 3x minus 150 degrees. So we're going to go back to degrees. And when you're looking at this, this is not in the best format to help you graph this effectively, so I'm going to rewrite it. The first thing I want to do is take this part right here normally we want to start with A. So I'm going to take this whole bit and move it to the front. So we're going to call this -2 secant, right? Because this is plus -2 when it's minus. So -2 secant. And then I want to factor. So we're going to call this 3 times x minus 3 goes into 15 5 times, 50 degrees. And then we're going to take this 5 and move it at the end, to the end. So then plus 5. That's in a much better format for what we need to do. Okay, we're going to go ahead and graph the related cosine function. So let's see. This should do it. All right, I'm going to go ahead and do at 50, 1, 2, 3, 4, 5, a vertical line. And then here's 1, 1, 2, 3, 4, 5. There's my horizontal line or my midline. Then I noticed that A is -2. So I'm going to be going up to 7 and down to 3 when I'm making my cosine graph. And then for the increment, one period is going to be 360 degrees divided by 3, or 120 degrees.
I have a question.
Sure.
For the x-axis, do we need to draw all those little dots? Can we just draw like slashes where like the increments are without drawing the little?
Yeah, that's fine.
Okay.
I just did that so I could plan out where I was going to mark my 50 degrees. My goal is that you guys can get pretty fast at drawing these, so when you hit calculus, it's not something that takes you a long period of time. So even though I go slowly and I'm writing all these things down, these are the things that might make a difference when you're doing where do graphs cross, or you're trying to rotate things around axes or lines. So I just want to make sure that you can find them. But in calculus, you're going to be just getting these rough sketches mostly. The increments, by the way, are at 120 degrees divided by 4. So every 30 degrees. So you're going to start at 50 degrees. And then 30 degrees later, 1, 2, 3, we have 80. 1, 2, 3, we have 110 degrees. Then 1, 2, 3, 140 degrees. 1, 2, 3, 4. One more time. Is 170 is where we're going to end. So I'm going to want to see these points marked on your graphs when you do your graphs for quizzes and tests. Then we're going to do, noticing once again, the secant is the reciprocal of the cosine, so we want to graph the cosine function. And -2 amplitude means it's going to be upside down. So instead of starting at our high point, we're starting at our low point. So we're going to be at 3 at 50 degrees. We're going to be at 5 at 80 degrees. We're going to be up to our high point 7 at 110. back to the midline at 140, and back to the low point at 170. And I'm doing a dotted line to represent the cosine graph. Now I want to show you there's two different ways that you're going to be expected to do this depending on who your calc teacher is. First of all, everyone will expect you to have these asymptotes shown right here. The one that goes through 80 degrees and the one that goes through 140. When you're doing your graph, all your teachers will expect to see, all your teachers will expect to see this part. They'll all expect to see this part of the graph. Here's where there's going to differ. Some will expect you to write one period by finishing up the low point at 170 degrees and marking off that it's going towards the asymptote. Some of the teachers are going to want to see unbroken parabolas. These aren't really parabolas, but for the argument's sake, we'll call them parabolas. They want to see these unbroken figures, and these are kind of broken. So some of your teachers will want you to extend 1, 2, 3. Because you'll notice the asymptotes are going to be half a period wide. So here I've got half of the segment that's between the two asymptotes. If I go left, another increment worth, and draw another asymptote, then I can finish up this portion of the graph. So for my class, I would rather see the 3 asymptotes and have you have it off a little shifted. But when I first started teaching at Walnut, the teachers I was teaching with did it the other way, where you kind of did the half periods and the half of the parabolas. So some teachers will might want to see that. Just be prepared for either one. For the graph, just give me a third asymptote. And you find that by going the length of one increment further on either side. So you could either do it on the left or you could have done it on the right. Okay.
So for homework graphing, do we do it this way on the screen right now?
Yeah, you don't have to show me that last little green one that's partial.
Okay. What about the right one? Do we need the right one?
Yeah, the right one you don't have to show me. But if you could show me the 3 asymptotes worth, that's what I'd like to see.
Okay.
All right. 2 more big concepts for today. The first one is we're going to graph tangent and cotangent graphs. And once you get how they're different than the sine and cosine curves, they're actually quite a lot easier to graph in terms of there's a lot less things to find out. And the other thing is we want to be able to write equations for graphs. So that's our goal for today. So we did secant and cosecant. Now we're doing tangent and cotangent. And for this, the pattern is dot, asymptote, dot, and so forth. So each time you're going to find the dot, then the next increment's going to be an amplitude, then the next one's going to be a dot, then the next one's not, I said amplitude. You're going to make a dot, the next important point is going to be the asymptote, then the next important point's a dot, then the next one's an asymptote, and vice versa. But in order to follow these, you have to be aware that a period is no longer 2 pi. One period is 180 degrees or pi. because tangents and cotangents, if you think about it this way, all students take calculus. Notice that every 180 degrees, they're back at the same sign that they used to be. So if they're positive every 180 degrees, they're negative every 180 degrees. So it repeats more often for the tangent and cotangent. So instead of dividing by 4, it's divided by, oops, I'm getting ahead of myself. Started talking about increments too fast. We weren't done talking about the period. So here the period's going to be 180 divided by b, or pi divided by b, where our generic graph is y equals a times the tangent of b times x minus h plus k, and y equals a times the cosine of b times x minus h plus k. Okay? Okay, the slope of the tangent has the same sign as a. If a is positive, it's going to be sloping upward. If a is negative, it's going downward. Cotangent is opposite. The slope of cotangent has the opposite sign as a. Then we still have, oops, we still have the same b as before. It still indicates our period. And our h and k as before still do the horizontal shift. So this, unless you have horizontal shifts, we have starting at 0, 0. And this one is an asymptote. So this might be HK if it's not 0, 0. So the tangent starts in the middle. And the cotangent starts at the left of a period. To find the increments, because we halved the period, the increments are now at a period divided by 2, because we've already halved it once. We only need to half it one more time. So we've cut the period in half because it's tangent and cotangent. So the increments are period divided by 2. And just like we did with the other ones, there are no amplitudes other than knowing if our sine, what our sine is for our slope. We have 2 examples, one for the tangent, one for the cotangent, and then we're going to move on to writing the equations from graphs. Okay. So let's go ahead and move on to our first example. Y equals 4 times the cotangent of x plus 3. So there's no horizontal shift here. but there's a vertical shift of up 3. So we're going to go ahead and get started with drawing our X and Y axis. And we're going to do a horizontal shift. This is my 1 right here. So 2, 3. We're going to do a, vertical shift up 3. I'm just going to go ahead and make my dotted line there. Then we notice that 1 period, we need to know what 1 period is 2 pi divided by, I'm sorry, wrong example. Cotangent is pi divided by b. In this case, b is 1. There's no number in front of the x. So that's pi divided by 1, which is just pi. So our period is pi. Our increments then are pi, every pi divided by 2. So here's 0. Let's go 3, 1, 2, 3. We'll call this pi over 2. And we'll go another 3, 1, 2, 3, and we'll call that pi. I've marked off the increments now. Because this is cotangent, my asymptotes are going to be at my starting point, which is 0, 3, and at 1 period later. Because the asymptotes for cotangent and tangent are 1 period apart. I'm going to write that down. Okay. Now the increments are every pi over 2 units. So something important's going on. We have 0, and then at pi over 2 is another important point. And then at pi over 2 later, we have our next asymptote. So pi over 2 is an important point. And for cotangent, that is where our graph touches the midline. So we notice that the A is positive. So the slope of cotangent needs to be the opposite sign. So it has to be negative. So what we're going to do is we're just going to show going downward. And it's going to be concave up first. And then it's going to switch. But still go downward because the slope is always the same sign. And here it's negative. Now, if we were drawing more than 1 period, after pi, 1, 2, 3, you'd have another point. That's going to be 3 pi over 2. And then after that, 1, 2, 3, we'd have 2 pi. And we'd have another graph because this would be a second amplitude right here. I said amplitude, a second asymptote right here. But this right here, if you're asked to draw 1 period, is 1 period between the first two asymptotes. One more graph for today. Let's do a tangent graph. We have y equals -3 tangent of 2 times x plus 50 degrees.
It's on WebAssign. It says the 4.1 to 4.4 quiz is due like this afternoon. But what if we didn't have time in the morning to do it because we were doing the review?
I thought I had it due at 11:55
Oh,
p.m.
Oh, PM. Oh yeah, it says PM.
Okay, good. Good.
I saw it wrong. Oh, oopsie
That's
daisy.
okay.
Sorry.
No, that's good. I want you to tell me as soon as you notice those things. All right. We'll do one in degrees. So go ahead and make your X and Y axis. And let's see. I'll make every one of these. Okay, I'm going to move this over just a little bit for myself. I didn't move it.
Miss Shelton,
Yes.
my friend who does not have a microphone wanted to ask if we needed to do the review on WebAssign 2 times. There were 2 separate reviews, and he says that it has the same problems.
We're only doing the one that's marked as assignment 27. There's one that's not marked as an assignment, and I haven't gotten into that yet.
Okay, thank you.
So there's only one review assignment. Thank you. All right. So I just wanted to make sure I gave myself enough room. So I'm sorry that took a while. But let's go ahead and mark these. Here's 1, 2, 3, -1, and so forth. Okay. So the first thing we're going to do is we're going to find that there's a vertical shift of down. I'm sorry. This is going to make it upside down. Then we've got our B right here, and there's no vertical shift. So this one has a horizontal shift of left 50. This one has a period of 180 degrees because it's in degrees, divided by 2, which is 90 degrees, and an increment of 90 degrees divided by 2, or 45 degrees. So we're doing a horizontal shift 50 degrees. And so I'm going to go ahead and mark that down. For 1, 2, 3, 4, 5, there's -50 degrees. And I'm going to do my new axis. I'm pretending that's like my y-axis, even though it isn't. Now with the tangent function, which is different than with the cotangent function, is instead of having the asymptotes at the 0, that's going to be where you're going to cross the x-axis. So that's my first point. Then my asymptotes are going to be 45 degrees later. So 10, 20, wait, no, 10, 20, 30, 45. So here at -5 degrees, you're going to have an asymptote. We can also draw that sooner. So we can say at -45 degrees, 10, 20, 30, 40, way over here, 50, 60, 70, 80, 95, it's way over here, -95 degrees is an asymptote. We also have another important point at 40 degrees, so about right here. Oops, that's 20. 10, 20, this is 10 degrees. 10, 20, 30, 40 degrees is another important point. And then 45 degrees later at 85 degrees, 1, 2, 3, 45, you're going to have another important point where there's going to be an asymptote. So here there's asymptotes at -95 degrees, -5 degrees, and at 85 degrees. And we're crossing the midline at -50 degrees, and we're crossing the midline at 40 degrees. Now this is going to look like a cotangent graph, even though it's a tangent graph, and that's because it's an upside down tangent graph. There's a negative. So the slope has to match when it's the tangent and be opposite when it's the cotangent. So this is going to have a negative slope. And there's your tangent graph. And remember, there's no amplitude. A lot of times when I give a test, I'll say, give me the period, amplitude, blah, 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 all these things, and it'll have some tangent graphs in there. And you're supposed to know to just leave the amplitude blank, or DNE for doesn't exist. We have one more concept, 2 more examples, and then you're done with notes for today. Any questions about tangent graphs? All right, then good work, and we'll move on. Now we're going to do some writing equations of sines and cosine graphs. We'll start by drawing a picture of the graph. Okay, it goes through some points here, 2, 1, just so to make sure you can copy it. It goes through the point 5, 7. And it goes through the point 8, 1. All right. So copy the graph. And if you're given a graph, you might be given, more points. Might be going on, might not be given just one period. But you kind of got to figure out where a starting point is. So either you're going to start at the lower high point or you're going to start at the midline. So you're going to find a point that's easy to identify. If you don't have a nice, either a high point, a low point, or a midline point at 0, 0, you're going to have a horizontal shift. So I think that 2, 1 is a good location to start our equation for this graph. So I'm going to draw that shift. And I notice that, okay, if it's starting at 2, 1, that means that HK equals 2, 1. Right? Well, yeah. So it's got a horizontal shift to right and a vertical shift up 1. And I also notice no, it's not up 1. I am confusing you and I don't mean to. HK, that starting point, we don't know what K is, but we know that the horizontal shift is right too. So everyone with me on that? To find out what K is, we need to look at the vertical shift. See, I lied when I said that this dotted line here was your other point. I got carried away and too excited about the point 2, 1. We do know that there's a horizontal shift, so that's the first thing. So I want to locate my vertical shift and my horizontal shift. And the vertical shift is going to be at the midline. And the horizontal shift you're going to find using the starting point. So here in red, we found the starting point. Our vertical shift means it's going to be halfway between my low point and my upper point. So if I go from 1 to 7, right? If I go to 1, between 1 and 7, that's 6 units of a change. So halfway or 3 units later, there's going to be our horizontal shift. So this is our middle. And we notice that this is plus 3 here. This difference here, or maybe I should say minus because it's dropping 3 from the midline. And then from here to here is another 3. That means that A has to be equal to 3. And my vertical shift has to be up 4. So my H and K are 2 and 4 from that. And my A has to be 3 because it's half of the distance. It's the high highest y minus the lowest y value, all divided by 2. That'll give you your absolute value. Since this is upside down, my a should be negative, so it should really be a equals negative. Okay? So that's our step 2. Step 1 is we to find h and k using the middle and starting points. Step 2 is going to be to find a. We've done both of these steps already. So we find a by finding the distance from the top to the bottom point in the graph in terms of the y direction. Divide it by 2, and then we notice that it's upside down. So it's negative. The only other thing that we need to figure out is figure out what the period is. We need to find b, and we do that using the period. So in this case, the period is the distance it takes for it to repeat. So going from x equals 2 to x equals 8, we're going to take the difference, 8 minus 2, which is equal to 6, and that's going to be the period. The period is the distance to where x repeats. And we know that 360 degrees divided by b equals the period. Well, if you cross multiply, that means that 360 times 1 equals b times the period, or 360 equals b times the period. So if I want to find b, I just divide both sides by the period. So it's a new equation, but you can figure it out yourself easily. B equals 360 degrees divided by the period. That's equal to 360 degrees. And we found the period was 6 here, divided by 6. Let's do this in radians, because then our numbers are going to be smaller. Well, whatever, I already started with degrees. 360 divided by 6, which is 60 degrees. And that's everything we needed to write it. We just need to decide if it's sine or cosine. And because we start at the lower high point, it's cosine. So that was kind of a lot of work to find all the important points, but let's go ahead and use that to write it. So we have y is equal to, now we decided that a was -3, so -3. We decided this was a cosine graph, so cosine. We looked for b is 60 degrees, so it's 60 degrees times x. Now we look at the horizontal shift. The horizontal shift was 2 right, so this should be -2. And then the vertical shift is always equal to the midline, and the midline here was at 4, so it is 4. And that's our equation. All right, we have one more example today. I'm going to just pause for a second. I know this is a lot of information here. I made the numbers small, but you can see the whole thing. If you missed some of it, but you don't want to have to go through the whole video, you can take a screenshot. Here's our last example. Last example, let's do a sine curve. Let's say we know it's a sine curve. We know the amplitude is equal to 2. We know the period is equal to 5 pi. This has a horizontal shift at pi over 4, and a vertical shift is -3. It goes down 3. Okay, some of your homework is like this. It just gives you some information and you're practicing writing the equation. So first I like to write down the generic one. Y equals a times the sine of b times x minus h plus k. Okay, we know the amplitude is 2. There's actually 2 right answers here. It could be either positive or it could be negative. So let's write them both. Plus or minus 2 times the sine. Now let's find out what b is. So the period is 5 pi. 5 pi, wait, 2 pi, yeah, 2 pi divided by 5 pi equals b. That makes b equal to 2/5. So we're going to say sine is 2/5 times x. We're going right 4, so minus pi over 4, because inside parentheses it's always the opposite sign, plus the vertical shift is -3. So plus -3 is the same thing as -3. This has 2 different equations. This is not one equation. Either y equals 2 times sine of 2/5 x minus pi over 4 minus 3, or y equals -2 sine 2/5 x minus pi over 4 minus 3. Either of these will work for these situations. So when your homework, you're asked to find 2 different equations, you can just write plus or minus, and I know you mean that those are 2 different equations. And that's where we're ending today, because you do have your chapter 3 test today, so I need to give you enough time to work on that as well as your homework. Do you have any questions before we end the meeting?
Are there situations where like it's only like one of the equations will work?
Yeah, if they give you some initial conditions is what we call them. So they give you some more information that limits it. So they might tell you, you know, that after a certain amount of time, that the value is at a certain number. But not when it's just, if they don't give you more details about the amplitude, then there's going to be 2, right? If they don't tell you which direction you're going. Anything else I can help you with? All right, that's excellent. I'm going to go ahead and stop the recording. And it takes them a while to get these to me as soon as they get